All right, good morning. Welcome back to Elementary Calculus 2. We're going to talk about our one of our last chapters here, which is chapter 11 on probability. Okay. Okay, so this is a really good thing for people to know how to calculate probabilities. The first thing we're going to talk about is a probability density function. It's just a function, it's a continuous function. Okay. Actually, it doesn't have to be continuous. It will be for us for the most part. Okay, but it doesn't have to be continuous. You can still integrate over a discontinuous function. Okay, so if I had a function like this, like a little stair step thing, if I wanted to integrate over this, all I would do is add up the rectangles and go ahead and do that. So functions, they have, excuse me, they have to be continuous in order for you to take a derivative, but to take an integral, they don't have to be continuous. Okay, so we don't have to have continuous functions. They will be for us. The important thing is the function has to be greater than zero, greater than or equal to zero over the whole domain. And the function has to integrate out to one over its whole domain. I'm just going to put a D down here for the what you're integrating over. You can integrate for smaller parts, and that's a probability. But if you integrate over its whole domain, the whole probability distribution has to add up to one. Okay, whether that be a discrete probability with rolling dice, or if that's going to be a continuous distribution like we have in this case here. Okay, the cases that you're going to be dealing with are going to be continuous because we want you to integrate over them. So really, this is just an excuse for me to ask you more integration problems. Okay, and that's pretty much what this chapter goes into. Okay, so let's go ahead and we're going to start with a little example here. And I always liked this flavor of problem. Okay, we're going to say determine K so that f of x is a probability distribution. Okay, so, and they're going to give us, okay, by the way, f of x is equal to kx on the interval 0 to 3. Okay, and we can go ahead and do that. First off, kx between 0 and 3, that's just no matter what you're going to pick for k, okay, as long as k is going to be positive, we're going to be able to say that that's going to be a value like that. Okay, it's just going to be y is equal to mx, okay, or y equals kx. We're just going to get an easy function that goes through the origin, an easy line that goes through the origin. So let's go ahead and see what happens when we integrate this out. So we're going to go from 0 to 3 of kx dx, and we know that this integral has to be equal to 1 because all probability distributions, when you integrate them over their domain, they have to integrate out to 1. So let's go ahead and integrate this. So this is going to be k integral from 0 to 3 of x dx. We get a k. I always like to put the constants through the integral sign because that makes things a little bit easier to deal with for me. X squared over 2, and we're going between 0 and 3. Okay, we know that this has to be equal to 1 because it's probability distribution. They said figure out k so that it is. So we go ahead and plug in the values there. So we're going to have k, and we have 3 squared over 2 minus 0 squared over 2 is equal to 1. We go ahead and simplify this out a little bit. So we have k 9 over 2. 0 over 2 is just going to be 0. This has to be equal to 1. Solving for k, k is equal to 2/9. Okay, and that's pretty much all there is to these kinds of problems. Okay, so my f of x, beautiful, okay, is equal to 2/9 x. Okay, so the day after Thanksgiving, I hope somebody is okay, and we could do that. All right, so that is pretty much how we're doing that. If they ask us, hey, what's the probability that x is going to be between 2 and 3? Okay, all we're going to do is we're going to take this. So this is part 2 for this. We're going to go ahead and figure out the integral between 2 and 3 of 2/9 x. Okay, that's all we're going to do with this. So if they ask you like probability between two numbers, we're going to go ahead and do this. So we end up with the 2/9 x squared between 2 and 3. We're not going to set it equal to anything. We're just figuring out a probability at this point. So we have 2/9, and then we have 3 squared minus, oh, sorry, we integrated x squared over 2. So we have 3 squared over 2 minus 2 squared over 2. And of course, this is always the hardest part of every calculus problem, is figuring out the arithmetic after you get done with your integrals. We have 9 halves right here minus 4 halves. Okay. So we can go ahead and figure this out. So that's going to be 2/9, 9 halves minus 4 halves. I left them without trying to reduce because I knew I was going to need 9 halves minus 4 halves, which is going to give us 5 halves. And then we go ahead and say, okay, well, this is 5/9. One of the things about a probability is a probability always has to be between 0 and 1. Always has to be positive, which is why the function has to be positive. If they ask us, by the way, what's the probability that x equals, say, exactly 2? Okay, we're going to go from integral from 2 to 2 of 2/9 of x. Well, I don't really need to do this integral because we're integrating over a single point. This is always going to be 0. So anytime, this is a trick question, anytime that somebody asks you like, hey, what's the probability that x equals exactly a thing? What they're asking you to do is figure out the area under one exact point. So this is always going to be an area of 0. So you don't have to worry too much about trying to figure out what that probability is. So it's always going to be an interval that they're going to ask you about. They're always going to say, what's the probability x is between this number and that number? There's another trick question. What if we ask you like, oh, we would like to know the probability that x is greater than 2? Okay, actually, we'll ask it so I don't have to do an improper integral. We'll say, what's the probability that x is between 2 and 5? Okay, well, in this case, where is x defined? It's only defined between 2 and 3. So the only thing we can really do is integrate this thing between 2 and 3, 2/9 of x dx. Once it gets past 3, that we're not defined anymore. It could be defined, but the probability after that is going to be 0. So we just have a plus 0. We don't have to care about anything after the fact. Okay, you can even integrate 0 from 3 to 5 if that makes you happier that you completed the problem. But this is just going to be 0. We don't have to worry about any of that. So we would just say, okay, the probability of this between 2 and 5 is really the same question of what is between 2 and 3, because we can only really ask you where the domain is. Okay, and we're going to get to that in my next section, my next example for you here. Okay, for what we could actually ask you for different problems. Okay, so the next one, and your book has quite a number of these, and don't be intimidated by this. Okay, I know that they were scary when you learned about them in college algebra, and I get why they're scary, because you don't deal with them very often in math classes. You deal with them a lot in real life, but we don't deal with 20 over 9x to the 5. This is when x is between 0 and 1, and when x is greater than 1. Okay, piecewise functions. Okay, we deal a lot of these with real life. I mean, if you like, this time of year, we're going to be sending postage back to various people. When you buy shipping, like a lot of times, it's like if you buy over $100 and your shipping is free, until then, it just ramps up until you get to the free shipping. Or maybe they charge people a flat no matter how much you order, and then once you get to a certain break point, you go back to 0. So that would be, that piecewise function would be like, we're going to charge you shipping until you get to $100, and then it's going to be, your shipping is going to be at 0. Okay, from now on. So we do piecewise functions in our lives all the time, and we're okay with it. In algebra class, we don't deal with it very often, so this is a little bit scary. We have to see this in calculus as well. So we might get a probability distribution that says, okay, it's 29 x to the 4th between 0 and 1, and 20 over 9x to the 5th when x is greater than 1. And that's fine, because again, we don't even have to check to see if, it will be continuous, because if you plug in 1, we get 20 over 9 either way. Okay, so if we set x equal to 1, What happens on this part of it? We get 20 over 9 times 1 to the fourth, and then we're going to match it with 20 over 9 times 1 to the fifth on the bottom here. It's just 1 to the fourth or 1 to the negative 5. Either way, 29 times 1 is 29. These are the same. It's still continuous. It doesn't have to be, but it's nice that it is. Okay. So some of the questions they might have on this is, what's the probability that x is, say, less than 1, less than or equal to 1? Okay, all they're going to do is they're going to ask us to integrate this out from 0 to 1. We have, what is it, 20 over 9, 20 over 9, x to the fourth. Okay, and we're just going to go ahead and integrate that out. So we end up with 20 over 9 integrating x to the fourth between 0 and 1, which is 20 over 9 x to the fifth over 5 between 0 and 1. The 5 goes into the 24 times, so we end up with 4 over 9 x to the fifth between 0 and 1. Okay, so this isn't too bad. 4/9. We have 1 to the fifth minus 0 to the fifth, right? Which is going to be our 4/9. Okay, so that would be our probability between x's between 0 and 1. Okay, so far, not so bad with this problem. Now it gets a little bit crazy when it says, okay, what's the probability that, say, x is greater than 1? So we have to go back to our piecewise defined function. What's the rule when x is greater than 1? Oh, it's this rule. It's 29 x to the negative fifths. Okay, so it's 20 over 9 x to the negative 5. I just moved the 9 back up to the numerator, gave it a negative exponent to make it look like a calculus problem, because it's easier to integrate negative exponents than it is to deal with denominators. And all we're going to do is we're going to have to integrate this thing from 1 off to infinity. So we figured this out. We have 1. What numbers are greater than 1? All of them, right? Anything bigger than 1. So we actually go off to infinity, but we don't want to do that. Do you remember how to do improper integrals? I'm sure you do. So this is 29 limit. I'll pick t goes off to infinity. The integral from 1 to t, okay, of x to the negative fifth. And this is what we have to integrate. Okay, so not so bad. You have to remember how to do improper integrals, and we have to, what does greater than 1 mean? So like 1 from now until forever, and that's how that works. So this is just going to be 29. Let's go ahead and integrate. We have limit as t goes off to infinity. And I have x to the negative 4 over negative 4. All right, we just add 1 to the integral. So even if it's negative, the exponent is negative, we add 1 to the exponent. And we're just going to go from 1 to t. Okay, we have to do some stuff. 20 over 4 is going to give us negative 5. So we have negative 5 over 9, right? That's the negative sign. We have x to the, actually, let me write the limit first. I'll do it that way. All right, 20 over 9, 5 over 9. And then we have limit as t goes off to infinity. And we have x to the negative 4, or 1 over x to the fourth, from 1 to t. Now, here's the thing that I always like to do when I end up with a negative. As I say, okay, this is 5/9. Notice the negative sign is not there. Limit as t goes off to infinity, 1 over x to the fourth. I put it back down to the denominator because it's easier for me to think about limits this way. And we're going to go from t to 1. You flip the order of integration, that takes the negative sign out. Okay, and then we're just going to evaluate evaluate these limits. We have 5/9. Okay, we end up with 1 over 1 minus 1 over t, right? Limit as t goes off to infinity. Okay, and then t to the fourth if you'd like. Okay, we could do that. 1 to the fourth. Okay, and then 1 over t raised to the fourth power. As t goes off to infinity, this is just going to be 0. You don't need a L'Hopital's rule for this. It's 1 over a really, really big number. we know that that's 0. You know this limit. We taught you this in Calculus 1. You can go ahead and be assured that we are here for what's going on. So this ends up as being 5/9 times 1 minus 0, which is, of course, 5/9. Okay. If we go back, remember what we did for part A? What was the value between 0 and 1? Okay, remember the probability that x was between 0 and 1, which was 4/9, and the probability that x is greater than 1, which is 5/9. When we add these two up, we get 9/9, which is 1. We also confirm that it's a probability distribution because we know that the whole thing integrates out to 1. So that's very nice. Now let's do a slightly, we're going to keep working with this problem, and I'll ask you the one that's a little bit harder, and that's what's the probability that x is between 0 and 2? Okay, so at that point you say, oh, wait a minute, this is a piecewise defined function. What we have to do is we have to break up the integral between 0 and 1 of f of x plus from 1 to 2 of f of x. Like, why did I pick 1? Looking back up at the function, there's a break, right? There's a break at 1. When x is between 0 and 1, we have one rule. So we're going from 1 to 2. It's like, oh, shoot, we have to go from 0 to 2, rather. So we need the between 0 to 1 part, but then we need to say what happens after 1. We have a different rule. So we have to break up the integral into two different pieces. Okay, I don't need an improper integral for this because 2 is a nice number and there's no weirdness going on with anything else. The reason why this is a part A, B, and C is because we've already done between 0 and 1. We already know what this number is. We just have to figure out the integral between 1 and 2 now. So we just did this part, like that was part A between 0 and 1. That was nice of them to ask. Okay. We know that between 0 and 1, this is just going to be 4/9. We don't need to integrate this again. We just put this off to the side and say 4/9 plus, and we got some stuff to deal with. So we have 1 to 2 of 20 over 9 x to the negative 5 dx. And we just have to integrate this little piece here. So this is just going to be 4/9. Don't integrate this again. Leave it alone. Okay, and then we're going to have let's see, we're going to have minus 20 over 9. We're going to go ahead and say this is x to the negative 4 over 4. And I put the negative already in here. Okay, put the negative in there. And we're going to evaluate if it's from 1 to 2. Okay, we're just going to evaluate that from 1 to 2. So I'm going to do the same thing. I'm going to say this is 4/9 plus, actually, I'm going to go ahead and cancel out the 4 here to say that's going to be a 5. Okay. So we have 5/9. Notice I made it a plus, which means what do I have to do? I have to change the order of integration here. And this is x to the fourth down here. Okay. So just remember the negative means goes back in the denominator. Okay. And whatever is easier for you to do, if you want to type in negative 4th, that's fine. You want to leave it in the denominator, that's fine. I know that a lot of times people don't know their exponent or know their multiplication very well. So you might have to plug this into the calculators to put this in a format that's going to be the easiest for you to figure out. Okay, so this is going to be 4/9 plus, okay, when I have x to the fourth raised to the 1, we have 5/9 minus, this is 5 over 9 times 2 to the 4th power. Okay, and I'm going to add this up in a way that's going to be most convenient for me. 4/9 plus 5/9 is going to be 1 minus 5. This, I added these two together because addition does that. And then I'm going to go ahead and use a calculator. You're not going to see that result here, but I'm just going to type in 2 raised to the 4th power. 2 raised to the 4th power, which is 16. So we have 9 times 16 down here, because those numbers come up all the time. If you're ever going to be a math teacher, you're going to know what this is. This is 1 minus 5 over 144. And again, you could have put that in the calculator, that's fine, which is equal to 144 over 144. That's a fancy way to write one, minus 5 over 144. And I think that's going to be 139 over 144. That's a number less than 1. So I know that this is okay as a probability. Okay. This is probably the harder problem that you have. And it's only disguised as hard because it's inside of a piecewise function. And as long as you remember the break at the piecewise, where it changes rules for the piecewise function, you're going to be fine separating out those integrals. I mean, it's really a cheesy way for me to ask you like more than just one integration problem with more than one set of limits. I mean, that's really what it comes down to. But that is pretty much how you deal with 11.1, okay, and how to deal with all of this stuff. Okay, and that's pretty much what we have for you on that one. So probability, I know it sounds like it's going to be like an intimidating topic, and it can be if you go further, but pretty much the two problems that I have for you is figure out K, so the f of x integrates out to 1, and then B is like, okay, I give you this crazy function, which is stepwise or piecewise, and ask you to integrate over a piece that crosses one of the steps. Okay, and say, okay, I want you to integrate over these two pieces. And all you have to do is remember to break the integral, right? Where the two pieces stop, and just remember that, and they won't be quite so bad. But that's really what you're looking at. Okay, we'll go ahead and we'll cover 11.2 in the next video. And I wish you the best of luck doing your homework, and I think you guys will be okay. All right, so thank you very much for watching the video.